Right, so welcome everybody. Sorry about the short delay at the beginning of the welcome everybody. Sorry about the short delay at the beginning of this webcast. Our webcasting software.
Welcome everybody. Sorry about the short delay at the beginning
unfortunately
of the
stopped broadcasting my screen, and I had to add the data source quickly. So my sincerest apologies for that. Then welcome to the webinar. We are looking at how BIM mandates and client requirements unlock the value for owner-operators. And my apologies, I'm just having issues with my computer this morning. Let me just try and see if I can get to the to where I need to be here. There we go. Okay, there we go. Welcome, finally. So how do BIM mandates and client requirements unlock value for owner-operators? That is the webinar topic, and specifically myself, I'm based in Cape Town, South Africa, so I've got an outlook on this through a South African lens. At the same time, I do have some exposure internationally through some of the projects that our clients have done and that I have been involved with. So hopefully I can add to the conversation, specifically in South Africa, but also within other parts of the world where the BIM mandates might not have been taken up by yourselves or somebody else. Then what advantages could we get? You could even look at this from a perspective of a government or somebody like that, or a owner of a property group or property management, or if you're a corporate owner, somebody that runs a big business and you've got skyscrapers or large assets that you need to look after. Of course, these assets could be pretty much anything in the built environment, so the technology scales. The agenda for today would be ISO 11650, looking at the International Standards Organization ISO 11650 standard. Why is it important and why has it been globally adopted, and what advantages can we get from that? Then we'll have a quick look at some of the things that would follow from structured data, which is Dynamo, generative design, and the democratization of AI and machine learning. So the McCleamy curve after that, as a conclusion, basically, we will see that the value that lies within the adoption of these technologies, and then we'll just quickly discuss the future and what is required to take us into the future successfully and in competition with others. So first of all, what is the International Standards Organization? It is a ISO, and what is ISO 11650? So on the right hand side, you can actually see a very nice picture that was brought out, where we can see that we've got the information management within the asset and project management. So there's the information management, there's the asset and project management, there's the organizational management. So usually the owners would not get involved with the nitty-gritty of the implementation of ISO 11650 within their organization. Instead, they would be just knowing that they've got ISO 11650 being applied in the organization, that they are getting audited every year, and that based on that audit, they will be allowed to be part of something bigger, some supply chain, some contracts that require them to be ISO 11650 certified after the audit. But within that, you've got multiple standards. So as a standards organization, then there's one for asset and project management. Now, clearly, that would fall within the scope of somebody that has buildings or built assets to manage. And then within that, now we've got the information management, which used to be the BIM standards that were so widely available for different parts of the world, different standards applied. It wasn't unified, and so that is why it's important. So why is ISO 11650 so important? It forms it's an integral part of the asset and project management ISO 5500 and ISO 21500 standards, and ultimately falls within ISO 9001. So if you were within a design group or collaborators that are putting together a built asset for a client who's going to manage that asset, or maybe there is a management company that does that on behalf of the owner, and that owner themselves are then ISO 9001, then the operators would have to conform to ISO 19650 to fall within the scope of the necessary audits. So that is what is so good about it. ISO 19650 is a BIM standard that allows adopters to be certified, and that was a weakness with previous BIM standards. For example, the UK standard, or the PAS, not the official UK standards, but the PAS 1192 standards, which I'm sure many of us are familiar with. And in fact, the ISO 19650 standards are very close to what the UK standard used to be, and there's commonalities with a lot of other standards as well. So you'll find it easy to adopt. And so why is ISO 19650 globally adopted? It's a global accepted international standard that is widely used in organizations for traceability, and especially within engineering. So the core understanding of ISO, as I learned that way back in the day 20 years ago, is you must say what you do, you must do what you say, and you must be able to prove it. And that, of course, is where the documentation comes in. Historically, ISO came about because a nuclear submarine sank and the parts and assemblies could not be traced as to their origin and their quality. So in other words, if you, in engineering terms, if you are installing, let's suppose, I-beams on your skyscraper, then you would want to have for the batch of I-beams that you are purchasing, you would like to be able to trace that batch back to the forge or the mill, whoever created those I-beams, and ask for the certificate stipulating that the steel is of an acceptable standard. And if the building had to fall down, pray that it doesn't during an earthquake or something like that, and somebody sues and wants to know, okay, so what was the steel quality on that building? Is it because you've maybe used substandard steel that the building came down? Then it would be traceable. You would be able to go back and see that that I-beam has the actual metallurgical properties that was required, and that was done through sampling that specific batch. And for each batch that you've purchased, you've got that certificate. So that would be an example of the traceability that we are talking about. Of course, that's also part of the information management, but more on the build side, I would say, or on the asset side, the asset information side of the digital twin process. On the BIM side, or on the building information model side, that's where we are dealing usually with classification mostly, but we also start capturing some of the data going into the project information gathering phase, and then the asset information management phase, ultimately getting into facilities operations, the sharp end of the stick, where whoever is operating that built asset for the corporate owner is then able to leverage the benefits specifically of the optimization of the building. So how is the building operated? Are you saving money through saving electricity and water over the lifespan of the building? And then also through maintenance. So is there planned maintenance, is there preventative maintenance, and is there catastrophic maintenance? So of course those different categories that will give you different costs over the life of the project. So it's really looking at the long-term profit that you can gain from your built asset. In BIM, ISO 19650 provides the organizational structure to guide practitioners to provide the best service possible, and formalizes a repeatable and traceable process. So that is from project to project. And then ISO 19650 does not replace experience in the BIM world. It mostly provides structure. So that is true, but it does provide a very good structure. So it's a bit like a like a conveyor belt or an assembly line in a factory, where you can then leverage systems and processes that sometimes are repeatable, often are project specific, but share a commonality for achieving the best outcome for your project and for your property portfolio or your asset portfolio. With that, I'd like to discuss some of the items that we do have available. I'll just quickly show you what something would look like, what one of these documents might look like. This is a typical example of something like that, where it is a step-by-step assessment and a step-by-step management of the processes to follow throughout the life of a building, and that might impact in the following way. So I'd like to show you two things. The one many of you might be familiar with. These are the REBA stages. So in general, this following argument could be made, especially within the South African milieu, but of course also globally, that the owner operator might not understand everything about a building. That is not what they do. Just like they would not be a lawyer understanding all the laws about international trade or whatever is necessary for their specific organization to run, they will have experts to advise them on that. And so in the same way, when they purchase or when they commission a new building, let's use a building as an example, they would then give the responsibility of that to an appointed party, right? And that appointed party must then, right at the beginning of the building, advise the owner to the following. What is the, so in this case we've got the REBA stages. Just to explain this quickly at the top, we've got a chronological sequence from brief to concept to definition to design to build and commission to handover and operations. That's the typical cycle throughout the building, and that might take several years depending of the size and scope of the project. Now, what this does is it says during this concept, what can the model be relied upon? And this is interesting because we can see it's for brief performance requirements and performance and site benchmarks. And then there's the initial, what is necessary, the initial response to the brief, the aesthetic intent, and so these things are put out until we get to the more detailed aspects later on in the project. For instance, the regulatory compliance, specialist contractor design, the fabrication, the coordination, sequencing, the estimating, target pricing, the guaranteed maximum price, and then later on the as-built model. So after it was constructed, how good is that? And also the pre-construction. So that, of course, we want to minimize as much as possible things that weren't designed correctly in the original model, and we'd like to have clarification on that. That's usually just a cost to the contractors. We typically tend to want to minimize that through accurate design during the design phase to start with. And then also the associated sequencing. So that's on the actual project itself, and then as installed information. And then during handover, there we can see we've got the asset information model. That is after we've gathered all the information, we're now going to put something in place for the owner operator to put that into operation and maintenance, and then during operations to condition the data and to the performance and update the asset model as it is in operation. And this is what really we're speaking to, is how can you make money during that part of the process, which spans multiple years over the life of the asset. And then in addition to that, there's the output. In brief terms, just the project brief, the procurement strategy, the refinement, the concept approval, and so you can see within the REBA phases going further what parametric information is required. Now, these are the sorts of things that I'm sure that an owner-operator wouldn't be overly interested in, but that somebody that advises the owner-operator would be very interested in, and might even have some experience in the real world running projects like this for others, and their vested interest will be with the owner-operator and not with the supply chain. And that's really where the conflict comes in, usually because the owner-operator, they might be familiar with their own personal properties. They would hire an architect. The architect would take it upon themselves to manage the expectations of the client, and then to deliver for them a house that they live in. But when you're talking about $1 billion skyscraper, that's no longer a house, it's a much bigger project. Would you still trust the architect to look after your interests if they are acting in their own interests? And some architects might be of an unimpeachable character, and you could certainly do that. And there is scope within the ISO 19650 to do that. You can have different roles. So depending on the relationship that you have with the other person, but in general, we would recommend that you have somebody acting on your own behalf. And of course, that person also needs to inform you as to what your responsibilities are on the project, and when it is that you have to get involved, when it is that you'll have to sign off checks, and make sure that the balance then is also delivered to you in terms of project capability and project quality. And that is their responsibility, to make sure that the supply chain then reacts to what your input is and what their input is. And there's historical data, current trends and adoptions of new technology that will influence the amount of money that you could be making out of your asset over its life. So this is the rebus stages, which basically tells you, so what is the models supposed to contain, and what would they be relied upon. And that is the rebus stages. In conjunction with that, if you want to bring it home to South Africa, for those of you that are not in South Africa, over here, we can see that we've got, sorry, these are color-coded. My apologies. Just ignore the colors. But what you can see over here, it follows the rebus stages generally. Project initiation and briefing, inception, concept and viability, design development, documentation and procurement, construction and closeout. All right, so pretty much the same idea as what the rebus stages are, but they are covered in terms of the development manager, the project manager, the architect, the quantity surveyor, the structural engineer, the civil engineer, the electrical engineer, the mechanical engineer. All right, just in general, what are their professional liabilities? So what would they be responsible on over a project during the project initiation and briefing, the inception, the concept, viability, and so on and so forth. So you can see some of the items during the design development for a project manager, for instance, would be they need to agree and implement communication processes and procedures for the design development of the project. So there is where ISO 19650 could come in very useful. They must assist the client in the procurement of the necessary other consultants, including a clear definition of their roles and responsibilities, prepare and coordinate, and so on and so forth. All right, so these are the responsibilities of the various actors during the project, as seen through the lens of PROXA. Now, if we compare that to the information management assignment matrix that we would get from something like ISO 19650, then that is very nicely classified as such. It's called IMAM. And there we can see that we've got an information management assignment matrix. This is now the ISO standard. They recommend that you have an information management assignment matrix. And there we can see that we've got a key. And that key says who's responsible for undertaking the activity, who's accountable, who's consulted, and who's informed. And then who is represented here? We've got the appointing party and the appointing party's third party, if it comes to that. Then we've got the lead appointment party. I've been the appointing party's third party before, where the appointed party would have me advise on a in an advisory capacity with regards to software and the standards that they employ, where they might have the responsibility for running the project, but they might not have specialist knowledge. Then that would be somebody like myself helping them with that. All right, then we've got the bid manager, the design manager, the project manager, the site engineer, the quantity surveyor, the planner, and so on and so forth. And then BIM specialists, document controllers, quality managers. And then a consultant task team or subcontracted task teams. So you can imagine on a big project, there's a lot of people involved and we need to manage. So there's during assessment and need. And what we would do at the beginning of a project, this isn't fully complete of course, is that we would then look at, should this party listed in this grid over there be responsible for undertaking the activity? Should they be accountable for the activity completion? Are they consulted and are they informed? And so we can see that there's the assessment and need, the invitation to tender, the tender response, the appointment, and in addition to that, you can see ISO references. So within the ISO documentation, these are tasks that are clearly defined and specified and fleshed out in documentation that those specific people can then refer to on that project. So it's very formalized in the sense of the structure, but what is contained within that is going to be interesting. So at this moment, I'd also like to introduce one other document for you. It's from the British Standard, and it is the unit class project management. There's obviously a later table available, but I normally say to guys, well, for every decision or for every something that is required on the project or that is wanted by the owner operator, it says my building should do the following or should include this or that, or these are the aims with the building. We want to be, carbon as friendly with the environment as possible. We'd like to do this, we'd like to do that. All right, well, everything there has implications. And usually what I do is I look to the British standards because they've got such an incredible standard to go and have a look for. And so what a BIM specialist would do is they would look at a list or something like this. If they've already got a relationship with the client or with the owner operator, then we will say, all right, what is it that is required over here? So client requirements there's an appointment document, a brief, a buildability statement, a building registration application, a carbon roadmap, carbon strategy, community analysis, community tenant liaison plan, construction industry regulation scheme requirements. So how many of these things are going to be applicable on the building that you are doing? And then one can use that for guidance within the regulatory framework that exists within South Africa or whichever part of the world that you reside in. You can then try and map the British standard onto something that is applicable within your country. So all this, of course, is work that should be done and shouldn't be forgotten about during the process. And this is a good beginning just to see. So I usually use an example, and this is something that we do collaboratively within the project from the disciplines. We have a master information delivery program where, if you can imagine, you've got a restaurant within your, or a canteen or a kitchen or something within your building, and you need regulatory authority for that. Is it licensed? Is it not licensed? Must it have health certificates? Those are the sorts of things that the specialists would know about with the regulations. And so we'd like to know everything beforehand and accumulate that knowledge within the building. But it's dependent upon what you as the owner-operator initially require from the building. And so you can see this is quite a long list. And so I think the big thing over here would be to go through a relevant list with the BIM specialist and say, yes, I want this. No, I don't want that. Yes, I want this. No, I don't want that. And then to say some of the things that you want and some of the things that you don't want. And of course, as usual, for everything that you choose to to use on that project, that will have a cost implied, but of course that also comes with the opportunity to not only recoup that cost during the operation of the building, but to provide you with a source or stream of income that would then be over the life of the project. You could save a lot of money, and that is the important item here. But this is then the requirement from each and every task team and the different personalities within that project to go and make sure that who is responsible for what and when and where, they all know about this and they must put it together. Ultimately, we would put this together in a master information delivery, in a Gantt chart. Basically, we would want to make sure that from an information perspective, that we could manage that in the correct manner. Just trying to get my project open. Apologies. Just on the side over here. Let's duplicate that. Won't be a minute. Alright, so this is now the Autodesk Construction Cloud, where I just need to sign in quickly. Come on. Security, of course, is important, which is why we do these things. Quickly getting the code from my telephone, and we'll be in the account in no time at all. Right. Okay, let me switch out to the relevant project. I want to be in 2025, and specifically I want to just have a look at the docs, the bold, and I think within here, if we have a look at the scheduling. So if you use Microsoft Projects or something like that, then you can set something like this up. There's a schedule that already exists. And this would be an example of making plans from a Gantt chart to make sure this is obviously not entirely filled out from my side, but you can see the beginnings of it, that we have these items over here, which is scheduled, how we would like to manage that. And then in addition to that, we've also got the plans. And within the plan, if we click on the plan, we can actually start saying what is it that we need to do during this process so that we can achieve that goal that is within our Gantt chart. And so that would be, from an information perspective, what a typical BIM manager would try and achieve with each one of these items within the ISO 10650 standard, and ultimately to give you exactly what you want. So, to give you an easy example, let's put it this way. You have a building. The building is to be a hotel. The hotel is in a very picturesque area of Cape Town, and you want to have nice visualizations to sell and market your hotel to the rest of the world. And so you would like to have a certain type of render that you'd like to apply, and so you might say something like the following. Or you give the BIM specialist the instruction based on some of the images that you've seen online. You might decide that something like Lumion would be the preferred. It could be one of many, but Lumion is one of them. You might say, well, Lumion is one of the examples. This is typically what I would like to see the building look like ultimately. Great. The BIM specialist can then go and say, great, you've given me the instruction that you'd want to have visualizations like this, you prefer this solution, and we can apply that for you. So we will make sure that there is hardware and software and capabilities at the correct time to give that to you. But in addition to that, we will now also make sure from a materials perspective that each and every element within the model is going to be constructed correctly so that we can generate those materials within Lumion. And to go further, we can say something like the following, that, all right, for the mechanical engineers, they're not interested in things looking pretty, but within Revit they are very much interested in the thermal properties of the walls, and so they will use that as an initial pass for the thermal characteristics of their control volume boundaries and constraints. And so globally throughout the project we would want to have somebody maintain a materials library for each and every discipline, so that the mechanical engineers, especially looking at the architectural and the structural models that are linked into their project, can actually generate these control volumes relatively accurately, export it to GBXML, open it up in an analysis package of their choice, and then write the HAPS calculations back into the model so that that is available within schedules. So those are very technical aspects of the process. One of the things that we've seen now is just by stating how we are going to generate the rendering or the pretty pictures for marketing, right? So we might say, well, in that case, yes, that's important from the materials library. That's why we will maintain the materials library. However, we're doing the rendering in an external package. So we're not particularly interested in the Revit models themselves looking pretty. So you don't have to worry about the Revit materials from an appearance asset perspective, or you must just make sure that it's good for council submission. So then we must manage those materials for council submission, and we must manage the view templates for graphics overrides and also for filters, so that we can submit to the council only specific documents that are required to pass authorization and get authorization to build the building. So we'd like to expedite the process. And we don't want to do extra work. We don't want to be involved wasting your money, in essence. If you give us money so that we build this building, we don't want to spend your money doing things that we should not be doing. And so that is also the responsibility of your BIM specialist, to understand in detail what it is that the supply chain must do, so they don't spend time doing things like you haven't asked them to do. If they're doing things that they haven't been asked to do, it means they're wasting your time and your money. So we don't want that. And so that helps to minimize the cost. But every decision that you make within the process, where you are saying you want to do something with your building, you want to get some of the output, it also takes an input, and that input is what is important. So that is one of the ways in which you can think about your BIM specialist and what it is that their job really entails. So there's a lot more that can be said about that, but in principle, that is what we are looking at. So ISO 19650 gives us if you can think about that Gantt chart that we showed you, it gives you a time-based process procedure that iterates for different task teams and incorporates different roles so that they have responsibilities, and those responsibilities also extends to the owner-operator. And the next part of the conversation is leading up to what is required of you, and that is what I'd like to finish off with. So obviously I've just opened a window, scratched the surface to a much bigger topic in which you as an owner-operator might not be interested in whatsoever. Your speciality might be, you're you're good at running, let's say for argument's sake, hotels and casinos, or maybe you are in mining, you're mining gold, you're a geologist, you're something from you're an accountant, you're a businessman, whoever and whatever you are, or you're a committee, or you're not a committee, you're a board of a corporation. You don't have this experience within the BIM world. It's not what interests you. You are interested in money. Everybody's interested in money, surely, I hope, but also in a responsible manner. And so what we would like is a good outcome for the money that we spend. We would like to get value, and we want to make sure that nobody is being abused within the process, either on whatever side. We just want to have good value for our money. That is what matters to us, and we're expecting that to be competitive with respect to not only South Africa, but other parts of the world as well. And if we are responsible human beings, we'd like to be friendly to the environment and enable people and train people during the project so that they can go on to bigger and better things over their lifetime. All right, so that's the typical sort of boardroom speak, I suppose, that one can give for a project, over and above the fact, well, we want to invest money and we want to make money, all right? But these days, not just these days, but in the modern era, it's not at the expense of the planet, it's not at the expense of other people or nations, but it's in a collaborative environment where everybody hopefully gains from our human endeavor. And this is what these protocols can also help facilitate. So within the modern era, of course, we are moving towards this data-driven design concept, machine learning. Mostly within the Autodesk world, it's about machine learning, not so much artificial intelligence. They call machine learning artificial intelligence in the modern era. That's not strictly speaking true. Artificial intelligence is something that's much more complex than machine learning. And I won't go into that, but it's just a personal irritation of mine that people would call machine learning artificial intelligence when it isn't. But in any case, machine learning is still very, very powerful in the sense that a computer can do a design within a fraction of the time of a human being. And given complex equations with multiple inputs and multiple outputs, how quickly can we iterate over an envelope of possibilities for the inputs to get an envelope of outputs for the solutions, and can we then choose the most relevant one amongst those? Can we get something that will give us the solution that we want? All right, and so that is what traditionally, just to give you a quick background to this, we have something called Autodesk Dynamo, which within the Revit world, for those of you that are in the Revit world, you'll already know what Dynamo is, hopefully. But I operated in Dynamo for a little while, for about a year, and essentially it's a visual programming language for Revit that includes, and this is the Dynamo primer for anybody that's interested, but in essence, we would then script. We could then script in Python. We can script Python scripts as well. So anything that isn't available within this visual language of Dynamo, we can then type in code through Python. Not everything is possible, but most things are possible. And so that is the Autodesk Dynamo. Just to pose a question, to give an instruction, maybe multiple input, multiple output. But then we get to the interesting thing. Once you've managed to compose a question of this model, I call it a question. It could be an optimization. You could say, all right, what must I do to, if I iterate the layout design like this, can I get an answer for something like, give me a lighting analysis, give me a workspace analysis, how easy is it to move around on the floor, and so on and so forth. It's quite complex questions. The one that was typically used within the medical field in which I was practicing my programming would be if you have an operating theater in a large hospital, it needs ancillary services, it needs waiting rooms, it needs equipment, and that equipment and the waiting rooms and the spaces around that, all the ancillary services are shared sometimes, and that is code driven by regulatory requirements. And so you might pose the question, I've got multiple operating theaters on this floor, and how do I now optimize the space? Because per square meter, the design of that hospital is very expensive, and so I'd like to minimize that area. Can I play Tetris, for want of a better analogy? Can I play Tetris with the different rooms and the hallways and ancillary service rooms so that I can fit together these different operating theaters, of which 3 might share this, 2 might share that, and so forth, so that I can minimize the area? It's an incredibly complex question to pose of a model. It's not easy because it's not it's not a straightforward question to pose, and so you would want to run that and program that in a way, and that's what makes it very difficult. And so I like to tell people about, okay, we've also got this generative design, and the generative design, let me just open that quickly if I can. The generative design is not an easy thing to do when it comes to complex questions. For easy questions, it is easy. For complex questions, it is not easy. Now, there is some help within the generative design, but it is my contention that for larger questions, more complex questions, that is something that's best left up to really brilliant people, mathematicians and statisticians that are capable of posing these questions in the first place, because it is very highly statistical in terms of, okay, how many iterations are you going to ask the computer to run? Are you going to run 1,000 iterations, 10,000 iterations, 1,000,000 iterations? How long do you wait for those iterations? How many times are you going to alter the question and then run the iterations? Do you get the questions right the first time? Is the solution something that actually makes sense after evaluation from the engineers and the designers, and so on and so forth? And so if you wanted to compete with other countries as a country, as a company with other companies, some of these companies are global, of course, then that would be your aim, all right? But all right, it's difficult, and not everybody has the money or the expertise or the people to do that with all the time. And so then Autodesk, what is good about Autodesk and the development of Autodesk software that I find so interesting about the modern era is that Autodesk Forma, for instance, is now a democratization of that technology. It's recognizing that this is valuable, but it takes skill. And so we have Autodesk Forma that has come into the picture just recently. For those of you that have used Format in the past, just to sketch a design, Autodesk Forma is now the modern equivalent of, just waiting for this, there we go, is now the modern equivalent of the artificial intelligence based and generative design based result of that sketch program, right? So you can see, for instance, here that there are various different workflows that you can do. There's a lot of information that you can do over here. There's some analyses. I think let's just quickly have a look at the analyses and then see what is available to us. So there's area metrics, there's carbon, there's sunlight, daylight potential, wind analysis, microclimate, energy, noise. Those are the analyses that are immediately available to you. It's not something that you have to program into the models. It's not questions that you have to pose to the models. It's not iterations that you have to do. These things have been democratized. So you can, if you look at, I think a most visual one would be a detailed wind analysis. Let's see if we can navigate there. There you can see the results of a detailed wind analysis on a conceptual model. So it's saying based on how you shape your buildings, you're going to have an influence on the wind patterns around your building. And so that is most brilliant. But it's not only for wind, it's also for other things. And you can see on the detailed analysis, it even looks at the wind flow over the building per elevation, based on the windrows and how often that actually goes through. You can set the speed and test different scenarios to see for each direction of the windrows, does your design actually fit the purpose? Now in Cape Town, this is of course something that's very big. I don't know if you know about this, but they actually had to change the route of the Argus because of a specific building that they built in Cape Town. And one year I remember there were some Hollywood celebrities here, there usually is with this Argus, and then the wind just blew them off their bicycles and nobody could compete there because the wind was so strong rushing through there, it just blew people off their feet. All right, so now, and not only since then, but before then as well, the CSIR, which is a sort of a national research institute for science within South Africa, has a scale model within a big wind tunnel of the city of Cape Town and Table Mountain. And every time that somebody wants to go and put up a nice new building, they have to go to the CSIR and submit that model for wind tunnel tests. That costs money. And so that would be a requirement if you had to put up a building in Cape Town. All right, so what's the solution? Well, why don't you use Autodesk Forma first of all? At least you give yourself a good shot after designing in here to see, can I actually pass the wind tunnel tests? And then if you design according to Forma, then you stand a very good chance that it might just be a one trip to that CSIR wind tunnel for the analysis, get the pass, and you're out of there. Then you can build your building. Then it's not a problem anymore. Compare that to the past where we would have to say to an engineer, Mr. Engineer, please go and analyze this for us. Let's try it out. And then you go and see, does it work within the wind tunnel? And then it goes into the model. So into the real world. But so here's the thing is that, okay, in Cape Town that might be a requirement. So do it. But why not just do it anyway? Why not do it because you want people to feel comfortable in your buildings when they hear that this building was designed by architect so-and-so or commissioned by this and that engineer or whatever. And then, okay, great, these guys did a fantastic building, so I've got respect for them. And I really enjoy this, and so maybe the next guy can also use the same companies. And so this is actually what is the power, because the way that I see things, and it's up for debate, but most of this comes from structured data, being able in the first place. So some of the stuff, for instance, the wind analysis, it's just a shape. But when it goes into some of the other disciplines, for instance, quantification, sourcing suppliers, making sure that you've got the lowest carbon credits based on the suppliers. There are actually software within the Autodesk Stable online that actually does that in America at the moment, where they are gathering data on existing projects to see how to minimize using contractors and building up contractor history, being able to match contractors to suppliers, the suppliers or the commissioners. How do you say, the clients basically, whoever designs the building can then look at the contractors and see, okay, these contractors have got a good track list. This is the track record, and we'll use them because we're maybe in the same state. Okay, something like that isn't available within South Africa yet. We haven't got that sort of data, but we can still learn from what's going on overseas. Look at the trends, borrow from that, and then see is that something that is going to benefit us. All right, and I'd like to end off with these two curves. They're very important curves. It's easy to understand for pretty much anybody. I don't think you'd even need matric to understand this. All right, so anybody can understand this. It's a graph, which is basically effort or effect on the left-hand axis. I know it's not, it's like a quantification that you can really measure. And then at the bottom, you've got the preliminary design, the detailed design, the construction documentation, construction and operations. This is a very famous curve within the BIM world. It's called the McCleamy curve. And what can we see over here? We can see that we have the area under one of these curves. You can think of the amount of work being done, right? Or from the perspective of a BIM, from an operator, when must you spend the money? When are the people actually doing the work? When must they get paid? And so what you'll see is, from a CAD workflow, they get paid sort of towards the middle, and then it peters out. So this is traditional AutoCAD. This is this CAD workflow that you see there. Before that, we've got the BIM workflow. So you can see that the curve is now pushed earlier. This is where you use BIM authoring software like Revit. Revit is the premier or the most prominent software globally that people are using to model buildings with. So you can see how all that effort is pushed earlier into the project. But now look at the cost, right? And this you'll know as an operator. The further along in the project you are, obviously people are busy doing designs and basing those designs upon other designs. It's an interdisciplinary thing, you know. So if an architect deletes a wall to join two rooms together, and that wall was a bearing wall, then the structural engineer has to redo his structural calculations and redo his structural model. That then feeds into the mechanical engineer, because now he has to redo his calculations for heating and cooling loads analysis, and so we can carry on. And every time that somebody makes a decision to change something, and the later it is in the project, the more of a knock-on effect it has and the more money it costs. And that's the dangerous thing. You don't want to make design changes later in the project, because the cost, here's the cost of design changes. As you move through the project, you can see how the cost of the design changes just keep on increasing. And it's not even linear. It's somewhere at the power curve. And in contrast to that, take for instance the ability to impact the project. At the beginning, your design changes have a huge impact on how that thing develops. And the later on in the project, the less your ability to impact the project becomes. Right? So it's initial condition driven. It's very, very important to see that as an owner-operator. And how that is changing in the modern environment is that you have now, and this is theoretical, it's not yet, I want to use Afrikaans, dis 'n proses wat in wording is. It's a process that is currently, or it's a trend that is currently being established in real time, where we are having a shift of the curve. So again, in the background, you can see the shadow of your CAD workflow, the shadow of your BIM workflow, the ability to impact, the cost of design changes, which are small at the beginning and large at the end. But we are pushing, using this technology like Forma, which we've just discussed with the wind analysis. That technology is pushing the work towards the very beginning of the project to say, we need to come to a decision very quickly. You as the owner-operator have to be involved from the very beginning. Your BIM manager, your BIM specialist has to be involved from the very beginning to make those decisions quickly. Why? Because if you make changes later on in the project, you are going to cost the project a lot of money. In other words, you're going to be burning your own money. And if you come to that decision at the beginning, when we've got the ability at low cost to make design changes, to use the technology, the computers, the machine learning, the artificial intelligence, hit that thing with all we've got right at the beginning so that we can get to the detailed design, into the nitty gritty, and then push through that design as quick as possible and into the construction documentation and construction, then we're on a very good wicket. But it does imply that the money must come at the beginning, but at the same time, so must the outcome, all right? And that is really the lesson to take away from this. So in the past, traditionally, 1960s, 70s, 80s, it followed a certain process. Now it's following a different process. The computers have disrupted the technology, but we're on a good wicket with Autodesk because they are democratizing that technology for an average person running an average show without all that knowledge and the capabilities and the research and development and everything. Just to use the tools that's available, they can already make a very large impact on the cost of these projects. And so you should also see it like that, but rely on your BIM specialist to apply the systems that are in place, the BIM mandates that are in place to give you the solution, to give you a return on your money. And remember, this propagates throughout the life of the building right to the very end. So we do have a chat available here. If anybody has any questions, there's a question answer. We'll just wait a little while, and then I've also included some useful links over there. There is, of course, the International Standards Organization website that you can go to get the actual standards from. There's also a British standard take on that exact same documentation. For those of you that are interested, there's something called Autodesk University. It's coming up shortly. In fact, it will be in Las Vegas this year. as every year, and they will be showcasing all the latest things on the planet. So register now. You can attend that for free if you're online. If you're in Las Vegas at the time, of course, you can make a turn. There's the Micrographics YouTube channel. This might be not so applicable to an owner-operator, more towards the guys that are doing the modeling, as well as our webinar series, of which this is part. And then we've also got our micrographics blogs if you are interested. I don't see any questions coming through. So from my side, I thank you. Thank you very much for your time and your ears. And I hope that in the future we can have a positive impact on our building environment, a very large part of our planet and the energy usage. Thank you very much and enjoy your day.